Chapter 2.1, Solve a Simpler Problem. In this chapter, we'll be looking at problem-solving technique, whose premise is basically to help you look for patterns within information that's given and solving a similar but simpler problem to the one that you're trying to solve. Now here I've got some general tips for you of how to go and problem solve. Now one thing that you want to do to begin with when you're given some kind of a word problem is to make sure you read the question a few times over so you can get an idea of what's being asked of you. In the problems that we're going to be dealing with today, you want to look for patterns within the information that they give you, and you want to try and see if you can set up a similar problem, but one that's a little bit simpler than the actual one that you're trying to solve. And in that way, if you can find the patterns, then that will help you then solve the larger problem. Often it's important to take a look at what's being asked of you or understand what's being asked of you in the question. If you don't know what they're trying to get you to do, then you're not going to be able to be too successful. You want to take a look at if the question asks for an exact or estimated answer. Sometimes it's okay to simply estimate your answer, but sometimes they're asking for, most of the time they're asking for an exact value, so that could determine what kind of technique you're going to use. So once you have all these kind of things sort of sorted out within the question, then you want to kind of figure out what approach you're going to use before you are going to solve your problem. So what I've got here set up is a simple word problem. What's set up here is a picture of a rectangular campground. And the question says that trees are going to be planted around the border, around 3 sides of the campground. And if you notice that on one side of the rectangle there is a river, there's no need to plant trees along that riverbank side of the campground. You simply need to plant trees along the other 3 sides of the rectangular campground, as I've tried to show you here with my mouse. Now, some stipulations says trees are to be planted 2 meters apart, and there's going to be 1 on every corner. So you must have 1 tree at this corner, 1 at this corner, 1 up here on this corner, and 1 at this corner. So the question then is, based on these dimensions and this information that's given to you, how many trees are going to be needed to be planted. So at this point, this would be a good time for you to pause the video and take a look at the question once more. Take a look at what kind of information is given to you in the question, and then see if you can determine a simpler problem out of this question that you can then use to find a pattern and then apply to the problem at large. Okay, now that you've had a chance to try to come up with a solution here, here's my solution. So if you think about the simplest diagram that you could possibly draw for this scenario, it might look something like this. I'm going to draw a tree on the 4 corners, so it might look something like this. And that forms basically our rectangular shape for our campground, assuming that up here on the top is where the river is. Now I'm going to add 1 more tree down here, okay, simply because I know that this length down below is going to be longer than this length, okay, on the 2 sides. So if I label, then I know that it's going to be 2 meters apart, okay, between each tree. Then it might look something like this. Okay, so that's the simplest diagram that we could possibly draw for this scenario. So what I have in this simple situation is 5 trees, and if you count up the total border length, and I've got 2, 4, 6, 8, a total border length of 8 meters. Now, a very simplified diagram of this situation might look something like this. So in this scenario then, I've got a total border length of, we said, 8 meters. Oops. And I used 5 trees. Okay. Now, if I think about the next scenario, the next simplest diagram I could possibly use would be if I added one additional tree. Now, the only place I could add an additional tree would be somewhere along this bottom length here. I can't just add one tree to the side. So if I had done that, I won't actually do it with all the trees here because I'm going to run out of room on my screen. But if I did that, the simple diagram might look something like this. And in this scenario then, I've used a total of 6 trees and a total border length then 2, 4, 6, 8, 10. That brings me to 10 meters border length. Okay. Now, if I decided to do the next one, I would do 7 trees. Okay, and you can determine then what the border length would be. Now, what I've actually done though is I've actually skipped a few diagrams here. I'm going to jump something to something like that. And if I count up in this scenario how many trees I've used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 trees planted here. And my total border length will now be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 meters. Okay. So the idea now is, based on these diagrams, have I gotten enough to figure out what the pattern is so that I don't actually have to draw it for 110 by 180 meter rectangle here. So I'm just going to fill in this table, and a table is often a nice visual way to display the information that you've gotten, and then you can use that to help you determine the pattern. So we had a border length of 8 meters, and that was when I had 5 trees. I ramped it up to 6 trees, and I had a border length of 10 meters. And I skipped a bunch. Okay. But you could probably figure that if you had 7 trees, you would have a border length of 12 meters. And like I said, we skipped a bunch here. We got ourselves up to 22 meter border length when we had 12 trees. Okay. So from this, can you determine what the pattern is? Now would be a good time to pause the video and see if you can come up with a general pattern that we can then apply to the larger question. So now that you've had a chance to try and come up with a pattern, here's what it is. If you take the border length and divide that by 2, then add 1, that will give you the total number of trees that needs to be planted. And if we kind of make sure that that works in each one of these scenarios that we had tried previously, if we take 8 divided by 2, that's 4, add 1, we get 5 trees. 10 divided by 2 is 5, add 1, we get 6 trees. 12 divided by 2 is 6, add 1, we get 7 trees. 22 divided by 2 is 11. Add 1, we get 12 trees. It works for every one of these situations, so therefore we've got our pattern. So we're going to apply our pattern to the largest scenario that we were given in the question. So here it is. In our original question, it says for a border of 110 meters plus 180 meters plus 110 meters for a total of 400 meters. If we take the 400 meters, divide that by 2, then add 1, the total number of trees planted or needed to be planted is 201. So hopefully this problem has helped you see how to solve more complicated problems by finding patterns within simpler problems.